Hello, this movie is for mutually exclusive events and compound probabilities. So after formative 1, on page 5 of the guided notes, we're looking at mutually exclusive events. These are two events, two or more, that cannot happen at the same time. Some examples: rolling a 3 and a 5 on a standard number cube. This is a dice, is what that is. At the same time. There is no way to roll both at the same time. So those are mutually exclusive events. Selecting one animal and it being both a cat and a dog. Winning both the gold and silver medals in the Olympics at the same time. I know that you could win them in different events, but if we're talking about the same event, that might be a little challenging. So you can think up some more on your own. Mutually exclusive, not going to happen at the same time. If two events, A and B, are mutually exclusive, then what do you know about the probability of A and B? So if we take an example like A, students in calculus, and B, students in geometry, what's the probability of A and B? Selecting a student that is both in calculus and geometry. That probability is going to be 0 because it won't happen. There's no way that you can take calculus without having taken geometry. So, and probability of two mutually exclusive events with and is 0. If two events A and B are mutually exclusive, then what do we know about the probability of either A or B occurring? So, if they're mutually exclusive, there is no overlap. They are completely separate. So the probability of A or probability of B, we would add the two. We just add the probability of A plus the probability of B. Note, is there overlap with these events? Key concept is that probability of mutually exclusive events, if A and B are mutually exclusive, then A and B is 0. And the probability of A or B, you add the two probabilities. This is why I've said in the past that when you are using and, you multiply. When you are using or, you add. So probability of A or B is the union A or B. Students who attend Wycliffe and Upper Arlington can either go to Jones or Hastings. In the spring, 24% decided to attend Jones and 70% decided to attend Hastings. What is the probability that a randomly selected student is attending Jones or Hastings? So let's first decide, are these two events mutually exclusive? Can a student go to both Jones and Hastings at the same time? And the answer is no, because those are two middle schools. So a student going to middle school is going to go to one or the other. These two events are mutually exclusive. Therefore, when we are looking at the probability of Jones or Hastings, and that is this union right here is the symbol for or. So when we're looking at this or, because the probabilities are mutually exclusive, it would be the probability of Jones added to the probability of Hastings. Therefore, we're taking 0.24 plus 0.7 and getting 0.94. So about 94%. 0.94. We're going to keep our probabilities as decimals, and that's a 9. In the spring season, 15% of the athletes play baseball, 23% are on the track team. What is the probability of an athlete either playing baseball or being on the track team? So probability of either, we're going to ask ourselves, is this mutually exclusive, being on the baseball and the track team? And so I'm asking myself this question, and I've got to say, I think so. So I'm going to say yes, but put a question mark. If that is not true, let me know. So that means we can get the probability of baseball and add it to the probability of track, because we're looking at the or and events are mutually exclusive. So it's 0.15 added to 0.23, and the answer to that is 0.38, or 38%. So to summarize, union, I've been saying this term, and intersection, which happens in both geometry, in algebra as well as in stats, union means or, intersection means and. So looking at it visually, if we're giving the set of numbers for A is 1, 2, 3, 4, the set of numbers for B are 3, 4, 5, 6, or is going to be A union B, and it would be anything that's in event A or it's in B. So you can see both are colored, including the intersection of the two. If we're looking at and, which is the intersection of the two, there's only 3 and 4, and these two are found in both. So they are in A and in B. So a little Venn diagram to help you visually with union and intersection. Here's a Venn diagram representing the number of students in marching band and football. And are these two events mutually exclusive? I'm actually going down here to this. Oh, actually pause this movie, try these on your own, and then press play when you're finished. Are these events mutually exclusive? The answer is no, because of that 5 is in both. We've got 5 people both in marching band and football. How many students are in the marching band? That would be in the red circle, and that is 103 because we're taking the 98 added to the 5. Now those 5 happen to be in both, but they're also in marching band. How many students are on the football team? That's going to be 39 because we're taking the 34 and adding the 5. How many students are in both marching band and football? That would be 5 because they are in both. How many students are represented in this diagram total? This is where we need to add all of these to represent a total of 137. Let's go to our next slide. Pause the movie, try these on your own, and press play when you are finished. Using this data, find the probability. Now, as soon as we're talking about probabilities, we're looking at events to the total. Find the probability that a student's in marching band and plays football. So the and plays football, there are 5 of them. Out of how many total? 137. That gives us approximately, and I'm only going to put the decimal, 0.036. Find the probability that a student is in marching band or, which is union, plays football. And so the or, it could be any of them. Either in marching band or plays football is all 137 students out of 137. So this is 1 representing 100% of students surveyed are in either marching band or football. Find the probability that a student selected is not on the football team. So this is a complement. So the probability of not on the football team would be only the marching band and not in both. So that is 98 out of 137, which is 0.715. Overlapping events. Sometimes there's overlap between two things. They are not mutually exclusive events. We'll have overlap, just like the football and the marching band. So when we're finding probabilities, sometimes they're counted twice and we have to subtract that off. So for example, given a standard number cube, what is the probability of rolling an even number? An even, we know, is 2, 4, 6, or rolling a multiple of 3. 3, multiple of 3 we know is 3, 6. So overlap, we can see that we have 6 in both. So if we're finding the probability of an even number or multiple of 3, then we get probability of even, add to the probability of 3, but then we subtract off the overlap. Because that overlap is going to be included in both of these probabilities. So you've included those people twice. So we get probability of even is 3 out of 6, added to the probability of a multiple of 3, which is 2 out of 6. And then we got to subtract off the overlap, which one of the numbers is in both. So 1 out of 6, which gives us 0.6 repeating. So key concept, something you need to know. Probability of overlapping events is the probability of A or B is probability of A plus the probability of B minus any overlap, A and B. Because if you don't subtract them, you will get counting them twice. Here's an example. Suppose you have 7 index cards, each having on the following letters. So probability of BAG, union, which is OR, the probability of GAD. So let's look at BAG is this, and then GAD would be GAD. So the probability of BAG we know is 3 out of the 7 total, plus the probability of GAD is also 3 out of the 7. But something's happened. We've included these two twice. They are in both of these probabilities. So we have to subtract off 2 out of the 7 and then calculate, and we get approximately 0.571. Let's look down here. The next one. Try this next one on your own and then press play when you're finished. All right, DEF, and that probability is 3 out of 7, added to the probability of AFD, this is OR, AFD is AFD, which is 3 out of 7. And then we've got some in overlap. We have 2 of those in overlap. So we have to subtract off 2 out of the 7, which is approximately 0.571, the same as before. What is the probability of rolling either an odd number or a multiple of 3 on a standard number cube? Probability of odd or a multiple of 3 on a standard number cube. Well, the probability of an odd number is 3 out of the 6. Because in our 1, 2, 3, 4, 5, 6, odd number includes here, here, and here. So there's 3 out of the 6. Added to, we've got multiple of 3, which would be 1, 2. 2 out of the 6. Subtract any overlap, and we've got that this 3 is an overlap. 1 out of the 6, and we get approximately 6 repeating. Well, actually, exactly 6 repeating. Pause the movie, try the next one on your own. Press play when you are finished. Probability of a number less than 4, or, probability of either an odd number or a number less than 4. Sorry about that. So odd or a number less than 4. Odd numbers, we have 3 out of the 6. Less than 4, we have 3 out of the 6. Now, an odd number less than 4, there are 2 of them, 1 and 3. So we subtract off 2 out of the 6. Now we also get 0.6 repeating. Looking at a standard number deck, which is identified here, what is the probability of drawing a jack or a red card from a well-shuffled 52 card deck? Well, the probability of a jack is going to be 4 out of 52. Plus, because it's OR, the red card is going to be half, and you could put a half. I'm just going to keep it out of 52, 26 out of 52. Now, the problem is that these 2 cards have been counted twice. So we need to subtract off the 2 cards that were counted twice out of 52, because these are not mutually exclusive events. There is overlap. We have to subtract off the overlap, and we get 0.538. Okay, we're going to do a class survey. If you're watching this movie because you're absent, you can't, but go ahead and complete formative 2, and then bring that in when you come back, and I'll check it. Thanks for watching the movie.